Welcome to the deep dive. We take the research stack, you get the knowledge. Today, we're looking at the moon, our closest neighbor, right? We've studied it forever, but now we're actually planning to go back. And the big question is it just this, dead rock? Or could something actually be hiding there? Maybe beneath the surface.
It's a massive question, probably the biggest one in our immediate cosmic neighborhood, really. What we want to do today is kind of cut through the science fiction, the moon bases and colonies, and look at the hard science, the actual conditions. Is it possible, even remotely, for life to exist there, based on what we know?
Okay, let's dive in. So if you or I were just poof on the moon, no suit, what kills us first? What makes it so hostile?
Well, there are three really big ones. First off, no atmosphere, or practically none. It's almost a perfect vacuum.
Meaning?
Meaning instant decompression. Your body, well, it wouldn't cope. No air, obviously. But the pressure difference itself is catastrophic for, fluids, tissues, everything.
Okay, so vacuum. Check.
Yeah.
What about just staying warm or cool? Those pictures from Apollo look bright, but maybe looks are deceiving.
Very deceiving. Yeah, without an atmosphere to sort of spread the heat around or hold it in, the temperatures go wild.
How wild?
Like boiling point of water wild. Daytime highs can hit 120 degrees Celsius.
Oh, whoosh.
And then lunar night, it plunges. We're talking minus 170 Celsius.
Whoa, minus 170. That kind of swing, that's lethal in itself.
Absolutely. Most life we know couldn't handle that kind of rapid, extreme change. And then there's the third thing.
Which isn't about temperature, right? It's invisible.
Exactly. Radiation. Down here on Earth, we're protected by our magnetic field and our thick atmosphere. They act like a shield.
The moon doesn't have that shield.
Nope, no global magnetic field, vanishingly thin atmosphere, so the surface gets slammed directly by cosmic rays, high-energy particles from the sun, from deep space.
So solar flares, galactic stuff, just constant bombardment.
Pretty much. It's a lethal dose over time, maybe even quickly during a big solar event.
Okay, so vacuum, crazy temperatures, radiation bath. Sounds pretty conclusive. Game over for life?
Well, it definitely paints a grim picture for life on the surface. It's basically trying to break down organic molecules. But science rarely deals in absolutes, right?
Okay. So where's the glimmer of hope? What factors could maybe allow something to survive, even if it's tiny?
Two key things we look for: water and shelter. Water's the big one. Life as we know it needs liquid water, but even ice is a start. And scientists are pretty confident there is water ice on the moon.
Where? Not just lying around, I assume.
No, it's thought to be concentrated at the poles, inside deep craters where the sun literally never shines. These permanently shadowed regions, or PSRs.
Permanently dark, permanently frozen. How old is this ice?
Billions of years, potentially. Some might have arrived via comets hitting the moon way back when. Some might even be created slowly over time by the solar wind hitting the lunar soil. But it stays frozen because it's incredibly cold in there, like minus 240 C.
Okay, so potential water source, locked away in the dark cold. But what about the radiation and the temperature swings? How do you hide from that?
That brings us to shelter. And the most promising candidates are underground, specifically ancient lava tubes.
Like caves left over from volcanic activity.
Exactly. Millions, maybe billions of years ago, lava flowed across the moon. Sometimes the outer layer cooled and hardened, but the lava inside kept flowing and drained away, leaving behind these long, hollow tunnels.
Caves, basically, lunar caves.
You got it. And the roof of these tubes, the solidified lava and overlying dust, the regolith could provide significant shielding. Protection from the radiation, protection from micrometeorites, and much more stable temperatures inside.
Interesting. So if there is any life, or maybe evidence of past life, it would have to be in these super specific spots, underground, near the ice, probably microbial.
That's the current thinking, yes. We're not expecting, little green men. If anything exists, it's likely extremophiles, hardy microorganisms, maybe dormant, clinging on in these cold, dark, protected niches near water ice.
Okay, let's pull it all together then. The bottom line right now, scientifically speaking, life on the moon. Yes, no, maybe.
The consensus is no known active life currently, but the possibility remains. It hinges on finding those extremophile microbes, or maybe their biosignatures, tucked away in those polar regions, possibly linked to lava tubes and water ice. It's not life as we usually picture it.
And this is why everyone's suddenly racing back to the moon, especially the South Pole.
Precisely. NASA's Artemis missions, India's Chandrayaan program, ESA, others. They're targeting the lunar south pole specifically because that's where the PSRs with the ice are and where evidence suggests these lava tubes might be accessible.
So it's partly about resources for humans, but also this fundamental search.
Absolutely. Finding water is key for future human presence, yes. But finding out if the moon ever hosted life or still does in some tiny hidden way, that's a huge scientific driver. Are we alone, even in our own backyard?
Which leads to that final thought, something for you listening to chew on. If we do find something, even just a single type of microbe that can survive the moon frozen in ice or dormant in a cave, what does that tell us? Does it make it seem more likely that life isn't just an Earth thing, but maybe it's everywhere, just waiting in the strangest places?